We did system substitution. Our big focus today is on that isolation piece. So what happens if we're not given a y equals or x equals equation? So we look at these two equations, and unfortunately, neither of them say y equals or x equals. So we're going to have to make them say it. So if we look at this first equation, both of these letters are a good choice to get by themselves because there's no number in front. Both of the numbers are ones. That makes them a good choice. So this y over here is also a good choice. They're all ones. You can isolate this x and solve its system, but you're going to deal with fractions, and we don't want that. So all you have to do is pick one of these letters that doesn't have a coefficient, and we're going to get it by itself. For this problem, I'm going to get this y by itself. So at the end of this problem, my y is my equation, I should say, is going to say y equals something. Well, for y to stay, this negative x has to move. We do the opposite, so we're going to add it, because right now it's subtracting. We do that to both sides. The y carries down. 2 plus x, we could write it exactly as we see it, 2 plus x. I prefer to have the variable go first. Positive x, positive 2, I would write it this way. All I have to remember writing it this way is just to keep track of those signs. Both the 2 and the x are positive, so down here, when I rewrite them in different order, they're both positive. So I'll just leave the blue there. Get rid of that if I can. All right. Now that we have a y equals, I can take what y is equal to, and I'm going to plug it in right here. So we get 6x minus, parentheses, 2 plus x equals 13. Distribute that negative, we get this. Combine my like terms, so the 6x and the negative x, I get 5x. We add 2, add 2. And x equals 3. Now that we have what x is equal to, we're going to use our first equation right here. Plug in 3 for x, 2 plus 3, and y is 5. We write our answer as a coordinate point, 3, 5. So let's practice another one. We've got this equation right here. To isolate it, the best choice for us is we want to look for the variable that doesn't have a number with it. So not this one, not this one, not this one. This is the best variable to get by itself. Mathematically, you could get any of them by themselves, but you will be dealing with probably more complicated numbers. Each one of the ones I have an x over, you would have to deal with fractions and decimals, and I don't know about you, but I don't want to do that. So to get this y by itself, I have to move the 6x. So I do that by addition. I like, again, to have the x go first, so positive 6x, positive 19. Plug in for y over here. Distribute the negative 4. Negative 4 and positive 19 gives us negative 76 equal to 17. Combine my like terms, so I get negative 31x minus 76 equals 17. Add that 76 to both sides. We get 93. We divide by negative 31. and x is -3. So that's half of our answer. We plug that in right here. And y is 1. Last one we'll look at is what happens if we don't have a letter that's completely by itself. We look at them and they all have numbers next to them, so there's no clear-cut choice. What we're going to do is we're going to check to see which ones share common factors, a common divisible. So what we're going to do is we're going to start with this 4, and we're going to ask ourselves, does 4 go into 2? It doesn't. So I'm going to put a frowny face. That's a bad start. We're then going to check with this one. Does 2 go into 4? Yes. That's good. We now have to check, does 2 go into 12? The answer is yes. That's great. That's a good thing. So we're going to put a smiley face. Does 7 go into 4? No. Does 4 go into 7? No. So the best option was this 2. And we're going to see why it's the best option right now. By isolating this 2y, the first thing I'm going to do is I'm going to add the 4x. We're going to divide everybody by 2. And now we have y equals 2x plus 6. That is a great sign right here. No fractions, no decimals, we're ready to go. Just to show, let's say we picked one of these frowny faces. Let's pick on the 4y right here. If I do the same thing, you wouldn't do this twice on the same problem. This is, what I'm doing here in green is to show you why it's a frowny face. We would then divide both sides by that -4 here. And unfortunately, 7 and 4 aren't divisible. We're left with a 7/4 x. -18, -4, also not divisible. We can simplify and we get 9/2. If we had chosen this smiley face, we're dealt with these fractions. And that's what makes me sad. That's why I had the smiley face. Or I had the frowny face in that one. So choosing them mathematically doesn't matter. It's just how hard of a problem do you wish to create for yourself. All right, back to the problem at hand. Y is equal to this. We plug it in, 7x minus 4, whoops, getting ahead of myself here. The y has come out. 2x plus 6 equals -18. 7x minus 8x, because we're going to distribute, minus 24 is equal to -18. -1x minus 24 equals -18. Add 24 to both sides. This isn't x. It's a -x, so we got to get rid of that -1. And there's our answer, at least half of our answer. We're going to plug it back in up here. Y equals -12 plus 6, so y is -6. So even if none of them jump out at you as your perfect choice, go through and check, does one coefficient go into the other? So if you're given this problem, it's clear-cut choice that y is the one you want to isolate, but noticing that 2 goes into both the 12 and the 4, that would make it an okay choice as well.